So this is what we're going to build today, and it's one of those classic setups that's been around for, or in fashion for at least the last 5 years. And the trend was clearly started, I think, by this brilliant animation done by Method Studios. And the concept here is simple but extremely well executed. You take some mocap data and treat it in a very abstract way. And one of those treatments are those lines that are formed by the motion left behind of the motion capture data. In this case, they added a bit of dynamics. I won't go into that today. I'll just build those trails with you. And for that, we need some mocap animation. In this case, I went the lazy route and downloaded this clip here from Adobe's Mixamo, which is a ballet dancer's jump, I think. And under the download settings here, I made sure I downloaded it with skin and set the frame rate to 24 frames per second, which is Houdini's default frame rate. And then I downloaded this as an FBX. So in Houdini, the first thing I want to do is bring in that animation by dropping down a geo node and diving in there, and then using Houdini's newish KinFX tools, which make working with character animation really simple. So I'm going to use an FBX character import here, one of those KinFX nodes, and I want to point this to the file I downloaded by clicking here, navigating to the folder where I saved this file, and then pointing it to that dancing FBX file here. So now I can frame this skin that we imported, this robot mesh here, and if I hit play and maybe toggle real time here, nothing really happens. So let's have a look at what those individual ports spit out here by attaching a null, highlighting that here and wiring in the first. Not much happening here. The second, you can see a skeleton in his rest position there, and the third slot. And the third slot, if I reset that to frame 1, is where the skeletal animation is coming in. So to apply this animation to our mesh here, I'm going to attach a bone deform KinFX node to that FBX character import. And now you can see immediately set up so that character mesh is animated by this skeletal animation that we have in here. However, for my trails, I don't want those trails to originate from those characters' points here, which would look like that, which for my taste are a bit too regular. Instead, I want to use a scatter node, which I'll wire in the first node here. So it scatters point on this rest geometry here, this T-pose, which then are deformed by the bone deform SOP here. So you can see now we've got this animated point cloud dancing away. However, that still is too regular for my taste, so I want to use a neat trick to kind of find the edges of that mesh and only scatter points in the edges. That means the area with a high curvature of this mesh here. I can do that by using the measure node. Wire that in here. Let's highlight it and check the tool handle here. So I now get the visualizer. And in my measure node here, I want to store and measure my curvature on the points, and I want to measure the curvature. So now you can see we're getting highlights in those areas where we have high and low curvature. That means convex or concave parts. So to use this curvature in our scatter node and drive where we scatter points, I first want to rename this and also want to remap it. So the curvature ranges from not really arbitrary values, but you can see here it ranges from a rather low value to 1.33 something. And to remap and rename this curvature value, which when we middle mouse on our geo node here, we can see is stored in our curvature attribute here on the points. To remap that, we're going to use the attribute remap node. Wire this in between the measure and the scatter. And in here, we want to remap the curvature and then call this one density. Now I could either manually dial in those values of our curvature, the minimum and max, you remember this 0.013 to 1.33, or I can just hit compute range, and now Houdini automatically dug out those values, and I want to remap them to range between 0 and 1, like so. And next I want to go into our scatter node here and scatter by density, but use this density attribute we just created. So check density attribute, maybe uncheck the relaxation iterations, and now I can dial in how my density attribute is remapped and thus drive where those points appear. So down here in this ramp, I want to take the first point and drag that over quite a bit, maybe to 0.2. So now I can see those points are mainly scattered in those edges, areas with high curvature. Back into our scatter node, a total count of 1000 points is fine for me. Now what I want to do is recheck the relaxation iterations to push apart those points a bit and maybe increase them to 32 iterations, pushing those points apart even further. So now I get these points outlining the edges of my mesh. And now, if I go to the bone deform, I can see those points being animated. To later color those trails, I want to calculate the velocity with which the points are moving, and then later color them depending on their speed. To calculate the velocity, I'm just going to use a trail node and set this to compute velocity. And now if I middle mouse on this node, I can see I added a V node for velocity, storing the speed and direction in which those points are moving per frame. Now to finally generate those trails, again, I'm going to use a trail SOP, this time set to connect as polygons. I'm going to uncheck close rows. And in here I can dial in the trail length, which in my case I set to 32, which just looked good. And if I zoom out a bit, hit play again, I can see those trails appearing there and then disappearing after 32 frames. A few things to take note of. Those trails are somewhat jagged up here. You can see here or there. There are some edges and creases in there, and we're going to take care of that in a second. And also on those individual points, we still store their velocity at that respective point in the animation. So the first thing I want to do is turn this velocity into a color. So let's go here maybe. And to turn this velocity into a color, depending on the speed, I have to calculate the length of the velocity. That means the magnitude of that vector, which in turn denotes the speed. I can calculate this velocity vector's length by using the attribute adjust vector node here, which I'll wire in below the trail like so, highlighting this. By default, it's already set up, so it works on the velocity vector called v. So let's drag this down here a bit. And what I want to do is I want to check output attributes, and by default, it's set up to calculate this vector's length. So if I middle mouse on this, I now get a length here. And if I head over to the geo spreadsheet, I can see the length of those vectors vary between 8 and about 0. All right, back to our scene. Now what I can do is take this length, which is just a single float number, and derive a color from it using a color node, which goes below that here. And I want to set the color type to ramp from attribute. And the attribute I want to use as an input is the length. And here my range originally ranged between 0 and 8, but I can dial that in to my liking so that this color range matches what I think those colors should be. And let's pick something else than this, just black and white. Ramp here, and instead go for some more colorful values in here. Maybe just pick a few values in here. I don't know, something like this. We can adjust that later. And then again, up here in the value range, I can adjust the overall look of this. Let's stick with that for now and take care of those jagged edges that we saw somewhere in the animation, for example, up here, by adding a resample node, which you can already see tries to distribute those points on those curves uniformly. However, when I drag its properties down here, the length of those points, the spacing of how far they're apart is a bit too big. So let's dial that down quite substantially to a value of 0.02 in my case, resulting in this highly subdivided lines here. And also down here, let's treat the polygon as a subdivision curve, smoothing it a bit, and output a curve U attribute. What the curve U attribute does is, on each point of those individual curves, it stores a value ranging between 0 at the first point of the curve and 1 at the last point of the curve. And we can use that to drive the curve's thickness, the width of it, over different parts of the curves. Okay, let's uncheck the point display here. Let's take care of giving those individual curves a width, a scale over their length. Again, by using an attribute remap attached below the resample node in here. And I want to remap the curve U. Remember, it's going from 0 at the beginning to 1 at the end of a curve. And I want to remap this to an attribute I'll create in here with this node called width. So my input value range I expect is from 0 at the start to 1 at the end. 0 to 1, that's fine. However, my output should be between 0 and 0.1, or maybe a bit smaller than that, 0.05 maybe, to make sure the width of those individual curves is not excessive. And then to be able to see this in the viewport, I'm going to go up one level to the geo level here. And in the miscellaneous tab here, I'll check shade open curves in viewport. And what that does is finally displaying the width of my curves that I just created. You can see here, they are going from very thick at this end to very thin at this end. I just want to slightly tweak this by dialing this down here and then adding a new point in here at 0.85 with a value of 1, and then decreasing this point's value here to 0. So we're getting this neat ramp over the life of these curves here, or over the length of these curves. And I think those curves are still a bit too wide, so let's add another 0 in here into the output max, and that's more what I'd imagine. One final tweak to this animation. Sometimes when those curves are really short, like in the beginning or the end of the animation here. When I rendered this in Octane, I got a few glitches, where apparently there were some, I don't know, wonky normals, which Octane internally calculated, resulting in what appeared like flashing lines or points. One last thing I'd like to address, which might be a bit specific to rendering this in Octane, is when I had areas where the individual lines were very short, or where there wasn't much movement going on in the points, I would sometimes get those flickering lines in Octane. And I don't know what's happening internally. Maybe Octane is calculating some normals internally and is getting confused by a very short point distance in those lines. Or maybe a scaling doesn't really work and scales the lines too broad, too wide at this point. But there was this one rather simple solution I employed, which was to just scale the width of the lines here by the length that I calculated up here from the velocity of my individual points. Again, using an attribute adjust, in this case a float goes after the attribute remap, and I want to adjust the width by using an attribute which I'll multiply. And the attribute I want to use to multiply my width by is the length. So depending on the speed of my animation at a given point in time, the trails at this point will be either scaled up or down. However, with this setup, my scaling here of the length can well go above 1. So you can see that here, that my trails are getting bigger than they were originally. However, I want them only to be scaled in the range between 0 and 1. So only allow them to be smaller than previously, but not making them bigger, which I can do by making sure that this length attribute is clamped. That means it's not exceeding values between 0 and 1, which again I can use the attrib remap for, going in the middle in here and just using the length, which I want to store as a length again, and just making sure it's between 0 and 1 and clamped to the edge values. And what I can do then is again use this ramp down here, this remap node, to drive those areas where maybe I want very little to happen. So back here where there's not much movement going on, I can scale those areas down by moving this point here in a bit, like so. And this is our whole setup for the trails. All I have to do is add in a camera, control click on the camera here, make sure it's locked to the viewport, frame it accordingly in a way that I like, and then light shade and render this in Octane. The only thing I want to mention here when doing that in Octane is make sure that on the Octane tab on your geometry node here, on the one hand in the attributes tab here, you have CD exported in your point vector attributes, so you can use it in shading to read in those colors that we calculated in here. And then under fur, let's check render as curves / fur object for this to be rendered actually, and those strands becoming visible. At this stage, let me point out one thing. Let's dive in there. So this is a rather lightweight setup, and I want to point out that we didn't use any VEX in this setup. We only used the default SOPs that Houdini ships with, and you can see that most of them come from the attribute group. Attribute adjust, attribute remap, and usually those would be nodes I tend to avoid and just spell out a line of VEX, which I personally find more compact and more readable than trying to go through the settings of those individual nodes. However, if you're passing on setups to artists, to other TDs, depending on their preference, they might find this one more readable, as usually there's only one thing happening in those attrib nodes. So they might have an easier time to isolate the node which they want to dial in values. I think Houdini is more akin to a development environment than a classical content creation app for 3D, and with that there are automatically a lot of different ways in which you could build your setups. And most of your choices depend on your personal preference or style. So if you're not working in a pipeline or a studio environment, you decide which way you want to go, this being the non-VEX way. So if you're intrigued now and want to learn more about Houdini, maybe a bit of Unreal Engine, want to get an in-depth view on what volumes are, rendering principles, particles, vellum, or maybe VEX, consider supporting us on our Patreon, where you can gain access to in-depth courses. Or if you plainly want to support us, head over to our Patreon. And a huge thank you goes out to everyone already supporting us, with a very special thank you going out to Rodeo FX, Important Looking Pirates, Sean Edwards, Chris Hebert, and Refé Canado. Thanks so much, folks. As always, I'm excited to see what you folks cook up using this technique, so don't be shy sharing. And until next time, it is cheers and goodbye.